So first, welcome to my Kotlin Multiplatform talk, and happy Christmas, everyone. Merry Christmas. I decided to just get in the spirit. Done. So, welcome. I've got here plenty of Kotlin stickers, if anyone wants. It's here on the front. And let me start by presenting myself. My name is Mota, and I'm Portuguese. So I decided that I might try to speak a bit Spanish, but in Portugal we call it Portuñol, and it's not the best thing, so...
Hola, bienvenido a mi charla sobre multiplataforma Kotlin.
Welcome. You can find me on Twitter at @Mota. I usually tweet about Kotlin, Android, or the occasional picture from a trip. And I've been developing for Android for the past 8-9 years. And basically for the past 2, I've been playing a lot with Kotlin Multiplatform and loving the idea of developing my business logic for both platforms. I've got some code on my slides. They're going to be available on Twitter, but you can also find it on Speaker Deck, so it can be easy for you to follow all the content. So a brief of history first, and let me just try to understand who's an Android developer here. Nice. Who's an iOS developer? Okay, nice. Okay. So who's developing for the web? Okay. And server side? Okay. The good thing about Kotlin is that you have this for all the platforms. Okay. Kotlin Multiplatform. So let's talk a bit of history of time first. So this is the world nowadays on mobile. Wait. Fixed it. This is the world nowadays on mobile. We've got Android and we've got iOS. This was the biggest feature of 2019, the dark mode. So this is the world nowadays. Now let's imagine, and please pay close attention to that image, because I was trying to search for an image with a computer, and we've got a nail here. I don't know why, but this is also PHP, so probably it's related. But let's imagine that we want to develop an application for both Android and iOS. Typically, we're going to need to hire a team for Android, a team for iOS. We're going to need to define the requirements, to design mockups for both platforms. And please do design mockups for both platforms. We're going to need to plan the feature development. We need to start development, write unit tests in one platform and the other. We're going to write the specification for the Q&A team to validate, and then we need to cross-check between both devices to understand if the behavior in one application is the same on the other application. And when this doesn't happen, we need to fix in the application the platform that is wrong. So typically, we're going to have 2 times the team, 2 times the cost, the status meetings required, the time spent on development, testing, and then the time spent on bug fixing. And now let's imagine that we want to add web to this. We're going to need to have 3 times the cost of all of these points. 3 times the team, the cost, the status meetings, the time spent on development, bug fixing phase, and on testing. Okay? This is a lot nowadays. So what we want to do is to cut everything on half. So let's find a solution that works on all of these platforms. And we've started this a long way back. In 2006, the first platform here, it was called PhoneGap. It still exists today. And the goal of each one of these frameworks is to develop an application that works on both platforms. We've been having a lot of these frameworks. Some of them are quite active, the others not. We've got Xamarin. Ruby Motion existed in 2012. And it was really strong in the first 2 years, at least in Portugal. And then it disappeared a bit. And nowadays we've got React, NativeScript, and now Flutter. Although these frameworks have a lot of advantages, meaning that you don't need a big team to develop. You typically need the half of the cost to develop things. And the learning curve, especially for people that are coming from the web, it's quite small when you try to go to use one of these frameworks. Of course, in case of Flutter, since it's a new language, it's a bit different. You've got a bigger learning curve here, but it's not that special. But it also has a lot of disadvantages. For instance, everything that you do, it's really chained to the framework itself. let's see an example. Imagine that on iOS 14, Apple decided to upgrade all the widgets. And if you're running an application doing native in iOS 13 and then iOS 14, if you're using the native components, if you're running on the latest version, it will automatically update. If you're using a framework like Xamarin or even if Flutter, if you're running the same application on iOS 13 and 14, you're going to have the same look. So this means that in case of Android, you've got a 10% update. In case of iOS, we're talking about 80% of the people update to the newest framework for the newest operating systems. So they will still have on your application the same look that you had on the previous operating systems. And this doesn't give the best experience to your users. Sometimes some native code needs to be written. In case of Android, this happens quite a few times because you have a big fragmentation here. So if you're using Xamarin, for instance, this happens quite a lot. But once again, it depends a bit on your project. It can make sense for your project. Honestly, for biggest projects, I would avoid using it. But of course, it's one of your choices. Also, and for me, this is really the worst point here, is that if you're talking about big projects, and for instance, I'm working in a project for the past 8 years, I'm also committing to the same framework for the past 8 years. Meaning that, for instance, let's imagine that one of these frameworks disappeared. You probably will lose all the support that you had on that framework. And if there is a new update and you need new APIs, that you need new widgets, probably will be the community doing so until one day that they decide to, okay, it's time to move on and leave this framework behind. And in that case, what will happen to your 8-year project? You're going to rewrite the whole thing. Probably can use part in that framework, part in native. It can give you a lot of work. So how can we have the best of both worlds? Wait for it. Still wait for it. Kotlin. So let's talk a bit about Kotlin. I have this video. I always love to show it.
Tyle keczupu Kotlin zmieści się na frytce. Tyle na kanapce. Tyle na burgerku. A tyle na żeberkach. O, a na szaszłyczku jeszcze więcej. Nie ma konserwantów, nie ma ograniczeń. Jesz tyle, ile ci zmieści. Kotlin, I love ketchup.
So I'm here to talk about multi-platform ketchup. So we've got ketchup, we've got mayonnaise. No, I'm joking. Kotlin started to be developed in 2006. It was accepted by Google as programming language for Android in 2017. And this year Google said officially that they are Kotlin first, meaning that the applications that they're making for Android, almost all the code that was written in Java now is written in Kotlin. So just to have an idea, let me start by who's still programming in Java? Better luck next time. I'm a huge fan of Kotlin. We had a talk yesterday about how they were trying to move from Java to Kotlin and the cost that it took to convince the management to do so. I've also been through that for 2 years. But I finally managed to convince my company in doing so. And for the past 2 years also, I've been doing only Kotlin and sometimes that bug fixing on Java that I cry a bit, but I've been doing mostly Kotlin. So Kotlin is developed by JetBrains. There is also the team that develops your main IDE for Android, Android Studio. It's open source. You can make features requests. You can ask a lot of features. And it's more than just for Android, meaning you can have it on native, you can have on the web, you can have on server. It also has a lot of features that are really, really good. And when I say that I prefer Kotlin to Java, I always need to say to people, remember that on Android we still have Java 8, we don't have Java 13 or 14. So we have a lot of features that aren't available just as is on our version of Java on Android. And there are still projects running Java 7. So this is a couple of features that I use every day. Okay, the most common one might be null safe. Okay, Kotlin is null safe by default, meaning that if you're trying to do an operation on something that might be null or not, the compiler won't compile your project. Of course, as you're a programmer, you can always say, okay, this won't be null, and if it's null, the program will crash, but by default, it can detect if your code is going to crash or not. You also have amazing things like default values and constructor overloads, for instance. This is particularly handy if you're doing views, and in Java, you would do something like you create a method, and then you create the same method with more one argument, and then create another method with more than one argument. On Kotlin, you can just use default values, and if you want to call them with all the arguments, you can call. If you don't call it. You've got type inference. You don't need to write the whole thing. You have end clauses. You have collections, and it's really easy to learn. Another cool thing about Kotlin when you talk about easy to learn is that if you're programming in Swift and you're trying to come to Kotlin, to Android, it's quite easy to do both things on both languages. You just need to have a syntax spreadsheet, let's call it, or cheat sheet, in order to see how things are doing in Swift. Let's see a simple example. On Kotlin, we have the concept of mutability, so we've got variable if you can change it and val when you can. On Swift, we've got the exactly same thing, but instead of calling it val, we call it let. Easy. If you want to see a function, on Kotlin we call it fun, because indeed we have fun. On Swift, we call it func. Okay? We've got string interpolation, meaning that I can use the $sign just to call the variable. On iOS, it's a bit more complicated. I need to put a slash, and I need to put parentheses on it. The return type is almost the same, so here I use the semicolon, here I will use an arrow. It's quite similar both languages. And we can go to a further example and see how can we call and create a class. And as you can see, the same thing that we have on Swift is quite similar on Kotlin. This is particularly handy if you want to do a Kotlin Multiplatform application and you end up doing both the UI on iOS and Android, because you can just have on one monitor your Kotlin code and the other the Xcode open, and you can just translate things as you're writing it. But I'm here to talk about Kotlin Multiplatform. So what's your first question? What is Kotlin Multiplatform? It's when you're using Kotlin in more than one platform. Easy. So let's see a common example. Let's imagine that we want to develop an application for Android, iOS, web, desktop, etc. Typically, and it will depend on your architecture, we can start by creating a presentation. And then we're going to create a model, a parser, your network requests, and then we're going to create a view. And we're going to do the exact same thing for all your platforms, okay? But although your view will change from one platform to the other, because you have different ways to interact. On desktop, you have a mouse to interact. On the Android, you use your fingers, and you have different types of components. Your business logic is going to be pretty similar. So what we want to do on multi-platform is not to share your UI. Your UI will still be unique, but we want to share your business logic. And with this, we're going to have less bugs, and we're also going to have less work, because the business logic that you develop in Kotlin, you can use in each one of these platforms. So what we want to do here, share your application logic. You don't need to share your application UI, although I've already seen some cool projects that are also using Flutter with multi-platform, and you can share the UI with Flutter, for instance. But this is not the major goal. It's one of the possibilities that you can do. So let's talk about a bit of the advantage of Kotlin Multiplatform. Of course, it's Kotlin first, okay? You have all the advantages of the Kotlin language here. It's low risk. You can decide what you want to share. For instance, you can just share your network model, for instance, or you can just share your preference. You don't need to share your entire logic. Honestly, my advice will be start small in what you want to share. It's interoperable. You can interact directly without any problems. And you've got consistency across all platforms. And for me, another of the biggest, strongest points here is that you have really strong community support. If you have any question, you can just go to Kotlin Land Slack and ask why this is not working, or what I'm doing wrong here, or can someone explain this? And probably in 2 or 3 hours, someone will explain to you what you're doing wrong and can help you. To be honest, this happened to me a couple of times, especially when I was using JavaScript. And I made several questions there, and it took me a while to understand what I was doing wrong. But after a week, I was able to have my project working in JavaScript without any problem. So I bet this is all your first reaction, right? Yay! So I'm saying that we're going to share code between a set of platforms. But there are things that are specific to one platform that are not specific to the other. For instance, on Android, we have the concept of shared preference to store a preference. On iOS, we call this NES user defaults. And we want to interact what the platform gives us. So this type of things needs to be defined platform-wise. So how can we expect to communicate? And what we do is we use the keyword expect when we expect the platform to define something. And then we use the keyword actual when it needs to be defined by the platform. Okay? Let's see a small example. Imagine that I have a really simple application that has only a label and says hello from, and it's going to say hello from Android and hello from iOS. So I want this name to be defined on Android and to be defined on iOS. So what I'm going to write is I expect that someone will define name. Okay? And then on my platform code on Android and on iOS, I'm going to define what name really means. So I create a class called platform, and I'm going to define what name means. In case of Android, Android. In case of iOS, iOS. And if you see here closely, you'll see that I'm defining this on a separated folder, Android main and iOS main, and we'll see in a minute what does this mean. A really cool thing about this is that when you define the expect, the IDE automatically will understand which platforms you're targeting, and it will say, okay, you need to define this on these two platforms. And if you press Alt-Enter, it will automatically create the files and everything. So basically, you can define what you want to be defined on a platform, on your common model, and then you can import it directly to your Android project, to your JVM, to your native VIA framework, or you can use it in JavaScript without any problem. On my opinion, the worst thing about Kotlin Multiplatform, it's when you start doing the project. Okay? When you first create a project, it's not as direct as I was expecting, because we still need to define a couple of things. For instance, when you create a project from template, you don't have your Gradle already created. You need to create via Gradle wrapper. And there are a few steps that when you're not familiar with the platform and the concept, it will take you some long hours to understand. So in order to be easy for you, I've written a small blog post with all the steps, and I am trying to create a template that works on all platforms, just so you can just import it and just run it without any problems. So let's see the code, okay? I've made a small demo for this conference. It was shared, it was the second conference application. And how did I do it? So on Android, on multi-platform, you can use it IntelliJ, you can use Xcode, AppCode, and Android Studio. On my opinion, I can use IntelliJ for both writing Kotlin code and Android Studio, and I prefer to only have one IDE, so I use IntelliJ, and you can use Xcode or AppCode for it. I use Xcode because it's free. Okay. So how this project is structured. So it's typically like an Android project. You've got your app, and then you have your source, and then you're going to have your common model. Okay. This represents your code that's going to be shared across all the platforms. And also tests, because they're important. If you're targeting Android, for instance, when you're going to define that you're targeting Android on your Gradle file, it will automatically create your Android main and your Android test folder. And if you're targeting, for instance, iOS, it will automatically create your iOS main and your your iOS main and your iOS test folder. And if you're testing for JavaScript, it will automatically create the same folders. So we're going to have them defined for each one of the platforms. A simple example of this project, and it's available on GitHub on this link. I'm using here a database. Okay, so in this case, I'm using SQLite, and you'll need to create your SQL code. I'm going to show this in more detail. This is just for you to have an overview. I'm expecting here that someone will define what the dispatcher is. And I'm now opening my Android code directly, defining what these dispatcher are, and I'm defining the UI code here, okay? Everything works as you're doing on Android Studio. You just have access to your, let's call it library code, your shared code. When you try to run the application, you just need to define your UI. In this case, I'm using recycler views and bottom navigation view. And I just define how I want to present this data. If we then go to Xcode, it's the exactly same thing. I needed to import here the framework only, and then define how I want my UI to look, which in this case, I've made it to look like the Android version. Just a heads up, I'm no iOS developer, so if you look at this code, probably it's not going to be the best code here on iOS side. You're free to make any pull requests for me to make it better. So the application is quite simple. We've got a recycler view. In case of iOS, we've got a UI table view controller. I'm making multiple network requests to get the schedule, the speakers, the sessions information, everything. I'm also parsing these responses, and I'm storing it on the local database, and then notify the UI and reload the entire components. If we're going to do this on the Android and iOS, and we're not going to use multi-platform, typically we'll use some of these libraries. For instance, I'm going to use Room for Database, I'm going to use Core Data for iOS, Retrofit, Alamofire, JSON, JSON serialization, RC Java, RC Swift, and then the part that is really different, it's the UI. So in case of Android, typically you use the activity, and in case of iOS, a UI view controller, and in case of presenting a list, recycle view and UI table view. If we're going to do this and share the entire logic, we can use all that multi-platform gives us and use SQLite. You can use Kotlin, you can use Kotlin serialization to parse the data. This depends on your architecture. I'm using MVP, I'm using coroutines, and then to test, I'm just using Kotlin test. This is basically the overview of the application. So these libraries will represent the network request and parser. I'm using models, presenter, and this is the important part. These three engines are being defined by the platform itself. Okay, you're going to see this on detail. So I'm going to define HTTP client for Android, SQL driver for Android and iOS, and dispatcher for Android and iOS. So if you want to present the same thing on iOS, it's exactly the same thing. The only thing that changes is the platform itself. So let's see how these work, okay? So now I have some code, bear with me. It's really simple. So, trying to not break anything. This is going to be my common main, meaning that all my code that's going to be shared, it's on this folder, okay? What I'm doing here is that I'm going to use Sessionize API. I'm making a request to Sessionize service just to get the updated information for the schedule. This HTTP client, as we've seen before, it's going to be defined by the platform itself. So someone is going to define this via the expect actual keyword. Here I'm just creating a HTTP client, and I'm just going to get this URL that has all the speakers. So I'm going, since I know that this content is a JSON, it's going to be on a JSON body, so I'm going to parse it, and this is as we do on Android. So this is my JSON response. I can identify here that I've got an ID, a first name, a last name, full name. So I'm just going to create a data class with these arguments, and automatically everything will be parsed, okay? I just need to say that this is serializable, and then I'm going to use Kotlin serializable that works just outside of the box. If for one reason you don't want to use the same ID that we've seen before, you can just create a new one and say, okay, the serial name is going to be tagline, but I want to store it on job title. This is, once again, this is quite similar with Android, and it works outside of the box. The database is a bit different, okay? I'm going to use SQLite for this. That works really, really well. And first, you need to define your database schema, okay? You're going to write SQL code. In this case, I'm just going to create a simple table with an ID and with a speaker, and just going to define insert or replace speaker, and then get all the speakers. Okay, quite easy. What SQLDelite is going to do is that it's going to compile this code and going to generate the class that I need to use. So they're going to create an insert or replace speaker, the ones that I've created on my SQL file, and then I've got all the information that I need right here. I just need to send an ID and the speaker object to be stored on the database. Talking about the model is just to try to simplify things. So instead of just accessing the code that was compiled, I created a data access object just to be more clear on how you can interact with the database. Someone received the message. Moving on, I've created a simpler model because I don't need all the speaker entity that I received on my on the response from the server. So I just going to use 8 objects. So I'm going to move this speaker entity to speaker object, and this speaker object is going to be used both on iOS and on Android just to populate the list. It contains all the information that I need, and I'm just going to use it directly as I would use if the class was on my project. A few more things. Let's see these get speakers. What I'm going to do here is that I'm going to fetch the speaker. So that first class that you saw, I'm going to fetch the speakers from there. So I receive here that Synchronize API. I'm going to fetch the speakers. I'm going to convert it to the object that I've mentioned before. And then I'm going to insert it automatically on the database. Okay? I'm going to insert all the speakers on the database so this information is available locally. When this information, if it's success, I'm just going to notify this on success, that as we're going to see afterwards, it's going to notify the UI that there is new data available. So let's see the presenter. Okay, this is particularly important because this is what's going to be called from your UI. So we're going to create a speaker list presenter on your UI, and we're going to call it attach view. And if you see here, attach view, it receives an interface that's defined once again on your common model. And this interface is quite simple. This interface has 2 functions, one called onSpeakersDataFetched, when this data is available and you receive the list of speakers. And you've got onSpeakersDataFailed, when it wasn't possible to download the list of speakers. Quite easy. And this interface is going to be called on the UI. So we're going to send an interface from the UI to your common model, and it will automatically be called when the information is available or when it fails. How can we do this? The onSuccess method that we saw before, we're going to map it on SpeakersDataFetched, and in case on failure, we're going to map it on SpeakersDataFailed. Okay? And the UI will be notified without any problems. Once again, on the presenter, I mentioned that HTTP client engine and database engine needs to be defined. So this code is going to be platform specific. So on this get speakers presenter, I'm going to send the Synchronize API and the speaker DAO. It's just initialization of those classes. And then the code that's going to be platform specifically, typically you use platform before to call it, to define it. And for that, I'm going to use, once again, the keyword expert and actual. So how are you all feeling? Like this? I know that it's too much information, but as you can see, you can do everything using the expect actual and code your code on Kotlin. So let's see. As I was saying, I'm expecting someone to define this HTTP client engine and this database engine. So it's quite simple. We just need to define this on Android and on iOS. And all the libraries that are now available already give you this outside of the box. So for Android, I'm going to use OKHTTP, and for the database, I'm going to use Android SQL driver. And for iOS, I'm going to use the iOS native, and I'm going to use native SQL driver that comes with SQLDelite. Once this platform-specific part is defined, everything works outside of the box. So let's see our Android code now now, and as you can see, we now move to common Android. As you can see here, we call the presenter that we've defined before, and we've got this attach view. Okay, this attach view, it's the method that's going to call the multi-platform code, and I'm going to send the interface that is defined on my my shared code. Okay, this iSpeaker data that I've mentioned that's going to be mapped in on speaker data fetched and on speaker data fileable. So let's imagine that we make a request. What it's going to be triggered is on this speaker data fetched, and automatically I'm going to reload the list and add all those elements to the list. A really cool thing here is that you can still use all the libraries that you're used to. For instance, if you're using Glide to set your images, you can still use them without any problem. Okay? Everything works independently. You can still use all your Android libraries. And you can still have, for instance, imagine that I've got this speakers part made on Kotlin Multiplatform, but I'm going to make a schedule request and I want to do it only for Android. I can have, for instance, Retrofit making that request, and I can still use the Kotlin code, the Kotlin shared code here. There's no problem. You can use it as a library, for instance. If we're going to use it from iOS side, it's the exact same thing. I'm going to attach view, define the interface, and when data is fetched, I'm just going to populate. I'm just going to populate my cells. So it's the same thing on different platforms. So we come to a question that is, what makes sense to share? Okay, and my best advice is what makes sense for you. Okay, there's no big goal to have everything shared. My advice is to start small. Okay, don't try to move everything to multi-platform. Remember that it's still experimental, and my best advice is start small and start doing it from one model to the other and see how your application behaves. How the time of developing new feature reduces, the number of bugs reduces. Just some quick conclusions. Typically, if you're going to develop an application nowadays for both platforms, you're going to develop it for Android and iOS. You have two separate teams. For instance, let's imagine that you have a library, and in my case, on my daily work, I have a C++ library. So typically, we have three teams. It's the exact same thing for Kotlin Multiplatform. Typically, we're going to have people allocated to do a mobile backend, let's call it this way, library, and they will need to document everything, to make tests, and to have a clean API. And this part of clean API is particularly important because from iOS side, you're going to import a framework. And that framework, it's not as easy to understand everything that there is there because it has some, let's say, it has too much code that shouldn't be there. You've got all what you see from Android side, you've got all the vehicles to strings, all those things that just pollute the framework. So you really need to have strong documentation on this, especially if you want to convince your iOS team to go for Kotlin Multiplatform. Typically, Android guys and girls are quite easy to convince. iOS teams are more difficult because it's a different language. And we'll conquer them step by step. I've made a quick exercise when I was doing this application because since I developed the backend, I wanted to have an opinion of someone from iOS side. So I just gave the framework and said, okay, if you call these methods, you can get this data, you can store it on database, this can be done automatically, so on. And this was his response, okay? He loved the idea that he didn't need to care about what's happening behind. He could just focus on doing the UI. He can just focus on doing animations. He can just focus on doing what he said that he knows best. Of course, this is the opinion of a single person, and most of iOS developers probably will feel that they're going to be losing control of their application, but there are others that prefer this part. Some final remarks. Remember that it's still an experimental state. Being said, 1 week ago on Kotlin, 2 weeks ago on Kotlin Conf, for instance, JetBrains announced Spaces. Spaces is a new tool from JetBrains, and it's all done on multi-platform. So I think he's still almost on a RC version, but they develop an entire system only on Kotlin Multiplatform. And you've got it for the web, for desktop, and for mobile. And since they're dogfooding their own applications, it's going to work. There are also other people working highly on the multi-platform. We've got TouchLab, we've got Square. The Catch app already has some cool libraries with it. My best warning here is that you might spend some time resolving compilation issues, especially when you decide to, okay, I've done this for Android and iOS, and then you want to add a new platform. You'd spend quite a few time trying to understand why it's not working outside of the box. But once again, the community is really, really good. And probably in 1 quarter, 2 quarters, everything will be outside of the box for you, and you can just create a project. We had a really big problem when I started, because there was no way to debug your native code from Xcode. And basically, you need to do prints and debug it from Android side, which is costly as hell. Fortunately, the people from TouchLab created a plugin that works really well on Xcode, and on Kotlin Conf they say that they're going to give this support once again outside of the box. Look out for plugins and libraries update. The community is really strong here, and we start to see a lot of good libraries made that you can just use, and it will help you a lot. I'm not tired to refer once again, the community is really, really strong, okay? Both Google and JetBrains are pushing Kotlin in. A lot of people are already use Kotlin. Kotlin was one of the trendiest languages of the past 2-3 years. You can ask them questions. It's faster to develop because you are going to share your business logic. It's way faster to write your unit tests because you only need to write them once. And in the end, it's a one-tech stack, meaning that you've got consistency across both platforms. And it also means that you're going, well, if you're going to have a bug, you're going to have it on both platforms. But when you fix a bug, you fix the bug on 2 platforms. So, yay. Some last suggestions. Once again, be careful with updates. When you update a library, remember to test on all your platforms. There can be subtle changes that change something that you're not aware of. Start small. Don't try to reach 100% of shared logic. Once again, it's still experimental. Do it at your own risk. And keep versioning in mind, okay? If something is stable in a specific release, wait a bit until you hear feedback about next releases, okay? Some last links. Once again, this is one of the subjects of Kotlin Conf. They are still publishing some of the talks. There are some already available. You can access them on this link. And of course, you've got a lot of Kotlin documentation on the Kotlin Slack, on the Kotlin official. You can just do Kotlin on the browser. You've got the Kotlin training, and of course, you've got Jake Wharton with a lot of Kotlin presentations. And you've got Antonio Leiva that's here, also with a lot of good articles on Kotlin. And since he's here, you can also talk directly with him. So, thank you. Do you have any questions? Do we still have time for that? Yeah, okay.
Hello. Can you hear me?
Yeah.
Okay. So first of all, thanks for the presentation. Have you tried to write the view controllers in Kotlin? Because I know that we can do that, but I'm getting problems and issues with the annotations. The object is out there and something like that. So have you tried it?
The question is if I tried to do a view controller from iOS on Kotlin, right?
Yes.
Yeah, I tried it with a really simple example that I had. It was like just a few labels, and it was really difficult to make it work, to be honest. So I decided, okay, the true goal of multi-platform is to share your logic. Mm-hmm. I'm going this way, and I'm going to leave this to be doing native. What I want to do next time and on this next year is I've read a lot that are people trying to do things with Flutter. So you're going to have Flutter to share the UI and going to have Kotlin Multiplatform to share your business logic. Mm-hmm. For me, that's what I want to test next. Okay. I've already made a small POC, but really, really small, that work with it, but I want to try, for instance, to have this application and then to move it to Flutter to understand if it will still work, which problems I'm going to have, and if it's still feasible or not. Well.
Thanks.
More questions?
Sorry, it's behind you.
Hi. So my question is going to be an example of SQLite, but it can apply on other different things. So instead of Room or Core Data, you used SQLite because it supports working with both Android and iOS, with SQLite on Android and with whatever is on iOS. Am I right?
Yes.
So does it mean that every dependency in a common model that you want to use, that dependency should support all platforms?
If you have that feature available, if you have the, for instance, if you have the feature of storing on a database available on Android and iOS, you will have to define on your Gradle file that you are going to use the SQLite library on the common model, that is your base, and then you're going to have the same implementation for a similar implementation that's going to be used on Android and on iOS. This also means that, for instance, if they don't have support for JavaScript, for instance, you're going to do different logic just to handle JavaScript.
Okay, but I'm still writing that in Kotlin code.
Yes, yes.
As part of my common module.
Yes, you write everything on Kotlin.
Okay, so that means that if I want to check battery state or network state, I need to have Kotlin libraries that know how to work with all my platforms.
No, you can use, if you have something that is platform specific, you can use, for instance, things that libraries that are available inside iOS. You have access to the iOS framework. For instance, I'm using iOS Create that is native from iOS, from the framework itself. So you still have access to the framework, and I could, for instance, I could use NES user defaults instead. If I'm using, for instance, shared preference, I could access directly to Android to use shared preference, and from iOS to use NES user defaults, and this could still be done on the shared model without any problem.
So in that situation, if I got correctly, I would have, let's say, access to iOS framework through Kotlin.
Yeah.
It's like port or something like that.
Yeah, you can basically, since you're compiling to a framework and you're compiling to native, you can access directly to that framework that's available.
Okay, thank you.
Just a small detail, that is, this works for 90% of the cases. I will not guarantee that it will work for 100%. I can say that for the time being, I didn't have any major issue. But I would say that if there is, someone will fix it quite fast.
More questions?